Uh, Thanks, Rich, very
Hi, I'm
much.
Professor James Adams, and I'd like to tell you about our research on microbiota transfer therapy for children and adults with autism and GI disorders. I'm going to summarize our phase 1 study and our follow-up treatment. And so this is work that I've done in collaboration with primarily Dr. Rosie Crouch-Balnick-Brown and Dr. Daewoo Kang. And here's a website, autism.asu.edu, if you want more information on what we do. I need to make a disclosure that several of my authors of this presentation have pending or approved patents related to the use of FMT and or probiotics for varying conditions, including autism. And we've received research funding from Christoval/Finch for our work, and some of us are part-time consultants for Christoval/Finch, and the other authors don't have any conflicts of interest. So first of all, we know that for children and adults with autism, many of them have chronic GI problems, primarily constipation and diarrhea. There's a powerful study, pilot study done in 2000, which was a small open label treatment study with the potent non-absorbable antibiotic called vancomycin. They treated the children with autism for 8 weeks. That's a long course, usually 10 days is enough. They treated them for 8 weeks to try to wipe out harmful gut bacteria. They found good improvements in GI symptoms and good improvements in autism symptoms. But unfortunately, after this long period of treatment, when treatment was stopped, within a few weeks, most of the gains, almost all the gains were lost, even though the children had tried regular probiotics in some cases. They also observed right at the start of the study, there was an increase in hyperactivity in about half of the participants, presumably due to when the bad bacteria are being killed off and releasing all their toxins, to causing a temporary worsening of the symptoms they had been causing. There's just a plot showing at baseline. By definition, symptoms were 0. There were big improvements on autism symptoms on a scale of 0 to 6 during treatment, but then after treatment, during follow-up, there was a loss of almost all of those gains. So this tells us that those bacteria are probably causing significant problems. We need to find a way to get rid of them long term. We did another study in which we looked at how the severity of gut problems was associated with severity of autism symptoms. So we show that on the y-axis are the ATEC scores, the severity of autism. We see that for speech, the group in blue, who are the kids with autism who had little GI problems, versus the kids in red who had significant GI problems. Those in red with GI problems had worse speech problems, worse social problems, worse sensory and cognitive problems, and worse physical and behavioral problems. So there's a strong correlation of GI symptoms with autism symptoms. So our hope is if we can treat those GI symptoms, we can reduce, not necessarily eliminate, but at least reduce the autism symptoms. We also, in another study, we looked at microbiome diversity. We found that children with autism compared to typical children had lower diversity of their gut bacteria, looking at both the species level, the CHA1 estimate. This may not look like a large difference, but it's in a log scale. So kids with autism were missing about 25% of the 1,000+ species there. So they're missing several hundred species of gut bacteria compared to typical children. And then also, if we look at the genetics of those gut bacteria, the bacteria in kids with autism had lower genetic diversity. In general, it's believed that when you have lower diversity of gut bacteria, that's associated with a less healthy gut. So we want to have a rich array of beneficial bacteria because our gut bacteria help us in many ways. So treatment implications, that probably a broad spectrum probiotic is needed, but unfortunately, most commercial probiotics only contain a few bacteria and not the ones needed by children with autism. And this suggests then that fecal transplant of beneficial bacteria from a healthy donor might actually be useful. So to give you a little bit of background on this treatment, C. diff infections are a nasty type of infection that causes life-threatening diarrhea in of order 500,000 Americans a year, and it kills about 29,000 a year. It can be treated with antibiotics, but about 30 to 40% of the time it returns again and again, eventually killing the patient in many cases. So it's been found that if you use fecal transplant, taking gut bacteria from a healthy donor and give it to someone with C. diff, usually 1 to 2 doses is enough to cure them of C. diff in 2 to 3 days with about 90% success. And what's even better is the recurrence rate is near zero, almost unheard of to reacquire C. diff after having fecal transplant. So fecal transplant is now used by hundreds of hospitals in the US to treat over 50,000 patients with C. diff. It's not yet fully approved by the FDA in the US, so it can only be used for treating C. diff patients, but phase 3 trials are now underway to have it fully approved. So in terms of considering the use of FMT for autism, one of our collaborators, Tom Borody, is a gastroenterologist from Australia. He's used FMT to treat nearly 15,000 patients, including 9 children with autism treated with a subset of 20 gut bacteria. And he found that kids with autism are much harder to treat than C. diff patients. So with C. diff patients, 1 to 2 doses is sufficient. For autism, he found he had to treat them every day for about 3 months in order to see improvement. But he was very stubborn, and eventually he did see improvement. So here's a direct quote from him. After 3 months of the cultured microbiota, there was a substantial improvement in bowel function, and the parents noticed a substantial reduction in the odor of their stool. Several children started the study with abdominal cramps, which disrupted their sleep. And by the end of the treatment, their abdominal cramps were reduced, and they were able to sleep throughout the night. Parents reported a marked increase in vocabulary, clear improvement in task performance, and new ability to listen to parents' requests. As a GI doc, he was very pleased to see the improvements in GI symptoms, very surprised to see also these improvements in autism symptoms, not something you might expect. So based on that, his work, we then went ahead and submitted a proposal to the FDA, and that research plan was approved for us to conduct a treatment study of microbiota transplant for children with autism. We give it a special name, microbiota transplant, because whereas standard FMT is just 1 to 2 doses, we first pre-treat for 2 weeks with oral vancomycin to kill off harmful bacteria. And then we do a day of fasting and a bowel cleanse to remove the vancomycin and to remove any remaining bacteria. And then we do high-dose microbiota, either orally or rectally. And then we do 7 to 8 weeks of low-dose microbiota that we give orally. We also give Prilosec, which is a stomach acid suppressant. So when people take the bacteria orally, normally the stomach acid would kill off almost all of those bacteria. So instead, we suppress the stomach acid so that way the bacteria can survive and multiply and grow in the gut. The microbiota we used are from our great collaborators at the University of Minnesota. It's highly purified, highly refined. It was more than 99% bacteria. Almost all the waste materials removed, and the children took it in a liquid form, mixed it typically with chocolate milk, and drank it down without any problems in almost all cases. So essentially, it's a super probiotic, but with 1,000+ strains of bacteria, those present in very healthy, very carefully screened donors. In terms of the participants, we had 18 children with autism, ages 7 to 16 years. They had moderate to severe GI problems. Most had constipation, sometimes alternating with diarrhea, and some had only diarrhea. We had to exclude the lowest functioning children who could not assent. All of these children we discovered had their GI problems since infancy. They were never normal. That was a surprise to us to realize that these GI problems generally started very early in life. And the vancomycin had a temporary adverse effect, just like in the Sandler study. 12 of the 18 children had a behavioral reaction to the vancomycin, started during the first few days of vanco, lasted 1 to 3 days in most cases, although one participant had symptoms lasting for 3 weeks. In 7 cases, it was mild to moderate increase in hyperactivity. In 5 cases, it was mild to moderate increase in tantruming or aggression. After the symptoms disappeared, then the GI symptoms and a bit later the autism symptoms began improving. This reaction primarily occurred in those with higher behavioral problems to begin with. So presumably if you had more of the bacteria which were causing those behavioral problems, then you'd have a worse die-off reaction. So our hypothesis again is that the vancomycin is killing off the harmful bacteria. They release all their toxins all at once. But then those bacteria are dead and gone, and then symptoms can begin to improve. In initial results from our study, we saw an initial 80% reduction in GI symptoms, which was great. And then we waited 8 weeks to see if those benefits were stable after we stopped treatment. And sure enough, those benefits remained 8 weeks. There was no loss of benefit, unlike with vancomycin, where vancomycin only, where the benefits were temporary. We also saw initially about a 23% reduction in autism symptoms. And again, those improvements were stable 8 weeks later. Now, this is an open label study, so there's some placebo effect. We believe some of these effects are real. And the microbiome diversity was initially 25% lower in kids with autism, and at the end of treatment, it had normalized. We had restored several hundred new species of bacteria in these children. But then several families came up to me a year later and said, Professor Adams, my son's doing better than ever. And so then we decided to do something very unusual, which is to do a 2-year follow-up. So we followed up with all of the 18 participants in our study. None of them had dropped out. All of them agreed to be re-interviewed 2 years later. And what we found is that there were no adverse side effects that occurred from the treatment, except one participant had some temporary worsening of behavior, which lasted for about 6 months before improving. The limitations of this long-term follow-up is that some participants had changed their psych med usage. 4 participants were taking slightly different nutritional supplements or had changed their diets. But our impression was that most of the changes were due to the MTT, and most of the participants had not made any changes. So in terms of the long-term results, the GI benefits lasted for most, but not all participants. In particular, there was one person who received antibiotics right at the end of treatment, and they lost their GI benefits, which was very unfortunate and also did not improve much more in autism symptoms. But most of those GI benefits were holding 2 years later. And the autism symptoms, most of the families reported just a slow, steady, gradual, continual improvement over the next couple of years. The child just seemed better able to learn, better able to learn language and behavior and social interactions. And so initially, our expert autism evaluator said there was a 24% reduction in autism symptoms, according to the CARS. 2 years later, she reported there was now a 47% reduction compared to before treatment. So that's a large effect, but again, it's open label. So we have to be cautious in interpreting the results. If we look at the GI symptoms, we see this is on a scale of 1 to 7. 1 is perfectly normal, no symptoms at all. And we see the group averaging over 15 symptoms, had quite a high average, and it dropped greatly during treatment. It was stable 8 weeks later. And 2 years later, most children still had low levels of symptoms, but a few had lost some benefit. If we look at autism symptoms, I'll focus on this curve here. At the start of the study, 85% were in the severe range, and only 15% were in the mild to moderate range. At the end of treatment, only less than 20% were in the severe range, 40% were in the mild to moderate range. And then if we look at 45% below the cutoff for autism, they still had symptoms, but they were generally not severe enough to be classified as autism. So that's pretty substantial improvement. Also, we saw improvements in the microbiome diversity. That this is a plot chart on the left here. This gray bar is the average diversity of the children with autism. The dotted green line is average diversity in typical children. At the end of treatment, at 10 weeks, the levels were very close. 8 weeks later, the levels are still very close between the typical children and the kids with autism. So it had been a big improvement. And then 2 years later, what was really interesting is that 2 years later, there had now been an even greater increase in their microbiome diversity above that of the typical children, perhaps because they had received gut bacteria from the very healthiest donors, the top 5 to 10% of the US population. Also, if we look at this chart on the right, this tells us about the engraftment. So initially, the gut bacteria are relatively distant from those of the donor. So plotting the distance or the dissimilarity with the donor. As after treatment, they become more similar to the donor. And at week 10, they're still more similar. And at week 18, they're still more similar. But by 2 years, they've now developed their own microbiome, which is now adapted well to the diet that that child is eating. But again, it's much higher diversity than that of typical children. So overall, very promising. So to summarize, abnormal gut bacteria seem to exist in many children with autism, including a lack of beneficial bacteria. Microbiota transplant is a promising, not proven, but promising method to restore normal gut bacteria and thereby improve gut symptoms and autism symptoms with minimal adverse effects. But we need to do randomized, double-blind, placebo-controlled studies to verify this initial pilot study. Based on our research, the FDA awarded us fast track status, meaning they've recognized that this is a potentially promising treatment for an unmet need. We still need to do phase 2 and phase 3 trials for it to become approved by the FDA and commercially available. So that's what we're doing. So currently, we're just finishing now a phase 2 study for adults with autism in collaboration with Dr. Richard Fry. It's a randomized, double-blind, placebo-controlled study. We're now analyzing the results. And we're also now halfway through a study of children with autism. Again, this is a randomized, double-blind, placebo-controlled study. And we've also just finished a randomized, double-blind, placebo-controlled study for children with Pitt-Hopkins, which is a genetic disorder which involves severe autism and severe constipation. So the goals of these studies are, first of all, to prove efficacy. Secondly, we're experimenting with different dosages and different durations. That our first guess was pretty good, but it was a guess, and we think that it's possible to improve on that by using a higher dose for longer duration, because the treatment seems very safe. So why not consider a higher dose, a higher duration? We need to determine if the vancomycin pretreatment is needed. Vancomycin is very good at killing harmful bacteria, but it also kills some of the beneficial bacteria. So that's a potential concern. And also, we need to try to understand what bacteria are changing. There's a lot of controversy in the research community. One group finds these bacteria abnormal, another group finds these bacteria abnormal. My interpretation is that many children with autism have abnormal gut bacteria, but it's very individualized to that child. So one child may have these bad bacteria, another child may have those bad bacteria. What they have in common is many of them have some bad bacteria that are at higher levels than in typical children. I want to thank the many people who have helped us with our phase 1 study and our metabolomics analysis, our funding from our university and state, and from Finch Therapeutics, providing some funding for the follow-up study and providing the drug for the study. And also funding from the Autism Research Institute for our first pilot study. The FDA has been very helpful to us for guidance. Of course, we need to thank all the families who have participated in our studies. These are complex studies. It takes a lot of effort by the families. Really appreciate the help. Especially, I want to dedicate this talk to Sid Feingold, who's a pioneer on investigating microbiota in children with autism, and Ellen Bolte, an autism mom, who really stimulated a lot of the research that led to what we and many, many others have done. So thank you very much for your time.
Thanks very much. I hope that talk was understandable. Rich, I think we're going on to questions now.
We're going to go on to questions. Yes, let's see. Anybody have any questions for Dr. Adams?
Thanks. Can you hear me?
Yes.
Great. So I noticed that on your limitation slide, there was this one sentence about a female patient in the MTT phase 1, I believe, trial that had just started their puberty and began menstruating. I was just wondering how the effect of that, and particularly estrogen, because it's been implicated as protective in various diseases, would affect the efficacy and safety tolerability of the MTT.
This was the one child we had, just the one female child in the study who just began puberty at that point. And all I can say is that it appeared she had very painful, disruptive periods, but it's not clear that was directly related to anything to do with the microbiota. So again, it's something we noticed and we report. And as we continue to do more studies, we may see that there's some role. It may not be indicated at certain points, but right now I wouldn't put too much weight on just one report.
Hello, I saw that you mentioned whether, the question, should we use vancomycin before or not? So what would be the criteria? How do you, what are the criteria to decide whether in general, like for the protocol, but also in individual cases?
So right now with both of the the randomized clinical trials that we're doing, the adult study with Dr. Fry and our child study, half of the participants are receiving vancomycin pretreatment and half are not receiving vancomycin pretreatment. So these studies will help us learn if we need to use vancomycin or not. It's possible that pretreating with vancomycin is helpful because it kills off the harmful bacteria, but it's also possible that it's harmful because it kills off some beneficial bacteria as well. So that's why we're doing the study, to find out. It's very important to realize that we have a lot to learn about optimal dosing, about optimal duration, that who is an optimal donor, who is an optimal recipient. Should we try to match donors in some ways to recipients, perhaps by matching them to a diet? So perhaps a vegetarian might do better receiving a donation from a vegetarian because their microbiome are very much affected by their diet. So we still have a lot to learn, and the vancomycin question is just one important question. The FDA is concerned about use of vancomycin because you can develop bacteria that are resistant to vancomycin, and that would be very bad.
Thank you very much for your wonderful presentation. This is a question that's actually coming up from our previous questions, as we discussed the microbiome makeup and some interventions with food, how to change microbiome. So do you think it would be beneficial to perhaps do microbiome sequencing analysis prior to the treatment to figure out the personal abundances of different bacteria, and then to do the same with the donor to try to better match and then figure out what's happening. And then furthermore, I think, as coming up from a computer science point of view, because, it would be very beneficial to collect these kinds of data, analyze and computationally find out who would this be beneficial for, and try to computationally find a makeup that particular treatment is beneficial for and not beneficial for. And I think, this is something that we can quite a bit learn from and come up with better treatments in the future. So just whether some of that is being done right now, and do you think it's something that would be beneficial to improve the treatment?
I think certainly the more we can learn about the microbiome and what is beneficial and what is not. And part of the complexity is it's not is a bacteria beneficial or not, but at what level? What is the optimal level so we have a good balance? So with one of the approaches that we're using in a study right now of probiotics, we're working with a company called Sun Genomics, which measures 1,000+ species of bacteria. And then they have an algorithm they use to try to determine which prebiotics and which probiotics might be best for those people. So right now we've enrolled about 300 autism families in that study, in which we've tried to tailor a combination of pre and probiotics for each individual. So each person gets their own customized probiotic. And we'll see in a few months what the results of that study are. But I think we have to realize it's very preliminary, that we have, I feel, a great deal to learn about which are the right bacteria to give. But I think very simplistically, if someone has an unusually high level of a probiotic, you probably don't want to give them more of it. But if they're missing some beneficial species, it makes sense to give that. So at the moment, we're doing full spectrum probiotic from very healthy donors. There are companies that are attempting to use just a subset of particular species, and we'll see how that works out.
Professor Adams, thank you for joining us. We have a couple of questions online that are in Serbian, so I'm going to try and translate them for you. Because
thank you.
Yeah. One question: can this therapy be considered as something that we should repeat after some years?
Maybe. With C. diff infections, it's almost never needed to repeat. We only followed our participants up to 2 years, but one participant spoke to me 5 years after treatment. I should say his father did, and just said his son's doing great. He's in college now and doing very well. He asked his son about his gut problems. He says those were long, long ago. So right now, we hope most of those benefits will continue, but there is a concern about the use of antibiotics. So far, we've had 4 people use antibiotics after FMT, and one of the 4 lost benefit. So antibiotics, I think, especially right after FMT, would be a concern. Also, remember that in this study, we did not attempt to change the diets of the children. So the only thing we changed was their microbiome. But I think eventually, when this becomes a clinical care, it would make sense to try to improve the diets. Many of these children are not on very healthy diets, eating a limited diversity of food and limited and often not very good quality food. And so trying to improve the quality of their diet, especially to make them fiber rich. In the United States, we have very low fiber diets, only about half of the RDA for half for women and only a third the RDA for men. So we need higher fiber diets because that's so important for producing butyrate, which is the main food for the cells that line the gut. So I think there's a lot more than just improving the microbiome, improving the bacteria, but also eventually improving the diet.
Thank you. Another question relating to PICA with kids that have autism. Have you seen any of cases with PICA and where FMT has helped?
None of our children, I don't think any of the children in our FMT study had PICA, but PICA is generally associated with nutritional deficiencies. In a study we published a few years ago, one of the children in our study had severe PICA, and they had also some of the lowest nutritional biomarkers, vitamins, minerals, etc. They could not tolerate our vitamin mineral supplement, unlike all the other children. But when they were switched to a healthy diet, healthy allergen-free diet, within 1 week, they were completely cured of their PICA. So PICA seems to be associated often with nutritional deficiencies, especially iron or zinc, and perhaps other conditions as well. So all I can say is in the one case, we saw a dramatic cure within a week just from a healthy diet.
Thank you. This is a question probably for all of our panelists and you too. Is there an option for a child from these regions to be included in research over in the United States? Is there a danger of a child from Macedonia to receive FMT from a US child? Because the previous panelist mentioned that microbiota is region specific.
So I'll give an answer. Certainly happy to have an answer from the many other great panelists we have here. At least for our studies, we're currently limited to US residents. And we've had huge numbers of applications for very, very few slots that we have. So if we can obtain more funding, we're happy to enroll more people, but at least for the moment, it will be people within the US because there certainly are differences in diet and hence differences in the microbiome between different people. But we think it's very important. With our studies, we use adult donors who are the top 10% healthiest people. And I think it's very important to receive donors who are very healthy, very well screened. And with children, it's a little harder necessarily to control their diets. They may not be as stable, and it's not clear that adult donors are necessarily the best for children. I should point out that in our study, we did use 2 donors for each person, one for the high dose and one for the maintenance dose. And the rationale there was that healthy donors have their own individual microbiome. So let's say one donor might have 1,000 healthy species and the other donor might have 1,000 healthy species. There's probably quite a bit of difference, so that combining, we might be getting 1,400 healthy species. So that's one of the unusual features that we did in our phase 1 study, is combine 2 donors.
Jim, here's a question for you that we get asked a lot. How far is MTT from receiving FDA approval and becoming an approved therapy for autism patients?
You know the answer to that probably as well as I do, but in the US, we require phase 1, phase 2, and phase 3 studies. So the study I presented today was our phase 1 study. The studies I'm doing with Richard Fry, that's a phase 2 study for adults, and we're also doing a phase 2 study for children. If those studies are successful, then we can move on to do a phase 3 study, but a phase 3 study would involve of order 500 people, about 10 different sites, and cost about $50 million. And so raising the funding for that is not easy. So we're probably quite a few years away from approval. What we have in our favor is that the treatment seems to be very safe, and we'll find out from the studies we're doing if it's significantly better than placebo. But it's probably at least several years away from approval for autism. But it's possible that it might be approved for C. diff within a year or two, in which case it could be considered to be used off-label for other conditions. But again, that would be at physician discretion, and I'm not advocating that. I'm just pointing out that legally it might be available for any condition once it's approved for C. diff.
Here's another interesting question. What do you think about using a younger sibling as a donor?
I would not recommend using younger siblings. In so many different studies we've done and other groups have done, siblings biochemically seem to be about halfway between kids with autism and typical kids. And so because they come from the same mother, you inherit most of your microbiome from your mother, and they've probably been exposed to their siblings' gut bacteria. I think that would not be an ideal choice.
Kind of along the same line of questions, as a donor, how do you feel about gender-specific donors? So boys receiving
Yeah.
Boys receiving girl samples and vice versa. Sorry about that.
Yeah, right now we aren't paying any attention to that. where our donors, we don't even necessarily know the gender of our donors. And so we are not discriminating who receives which. We don't think there are major differences in gut microbiome between men and women, but as more research is done, we'll probably find some small differences. But at the moment, I don't think it matters in general, except the women is, again, as I mentioned in the US, women tend to consume higher amounts of fiber, so the women might be slightly better donors in general.
Can you hear? Oh, sorry. Yeah. If I may add just to this, because I've been playing with microbiome data with different kinds of data sets in the last few years, and I love engendering research. I always like looking, whether something is different for different genders, and I haven't been able to find many differences between male and female microbiome. So just well, in bacteria, in terms, distinguishing, I couldn't come up with a computational model that with any sort of high accuracy could distinguish between male and female microbiome. But, the computational methods are getting more precise, but with the current state of the art, didn't mention that.
Other questions from the audience? Wow, well, that's wonderful. Thank you so much, Jim. It was
Could I
really...
make one closing comment?
Yeah.
So just one, although we've mostly been focusing on bacteria, I'd like to just briefly point out, I think it's also very important to look at yeast, that there are about 5 studies now showing that about 25 to 50% of individuals with autism have an intestinal yeast infection compared to a much lower percentage in typical children. And we have some unpublished data showing that the children with autism who have yeast infections have much worse autism symptoms, especially language problems, compared to children with autism who don't have yeast infections. So it's a very cheap test to do, a yeast culture. And although yeast culture isn't the most accurate method, we found that if you have a yeast culture, it's associated with much higher severity, that it's treatable, so that we have antifungal methods, and there are also culture-based methods you can use to determine which antifungal or herbal treatment might be best for treating a fungal infection. So our recommendation is that every child with autism should be tested for a yeast infection and then speak with their physician. If they have a yeast infection for treatment, I think that's a treatment. I think that's a test everyone should do, and a treatment that is under-recognized as to its importance. But we need clinical trials. There's only one very limited clinical trial showing benefit from antifungals. But I think it makes a lot of sense because yeast produce nasty metabolites. Alcohol is one example. And I think it's obvious to everyone the effects of alcohol on mental functioning. And yeast can produce some much nastier toxins, which also seem mostly not to be affecting GI function, but to be affecting mental function. So although again, we've mostly been focusing on gut bacteria, and that's where most of the autism research is, I want to point out there are several studies showing that yeast are also potentially very important.
I think one last question when you were talking about that. What is your opinion about changing the diet if you think there's any type of yeast infection? You think that's something that could be helpful?
Yes, I've heard anecdotally from many, many physicians and families that antifungals, after an antifungal treatment, the yeast will often come back in children with autism unless they put them on a very strict low sugar anti-yeast diet. And so I think that's also something very important. Dr. Fry and I submitted a proposal on that. Unfortunately, it wasn't funded, but we think that's a very important area to look at.
All right. Well, that was a wonderful lecture, Jim. Thank you so much.
Thanks, everyone.